Now, the time comes for calculating the probabilities for non-standard normal random variables. Remember now, not in all questions we are going to deal with standard normal distribution. In some questions, we are going to see non-standard normal random variables. So we need to learn how we can calculate the probabilities for normal random variables. And for that, we are going to use a standardization operation. Let's check the first example. It says, capital X is a normal random variable where the location parameter is equal to -3 and the scale parameter sigma is equal to 1. So the question gives me the parameters of this normal random variable, and it asks me the probability of this normal random variable to be less than or equal to -3.75. Now, I do not have any table regarding to that distribution. I only have a table regarding to standard normal distribution. So what I am going to do is to standardize these inequality. And remember now, the standardization is applied by applying this transformation into both parts of this inequality. So in both parts of this inequality, I'm going to apply this linear transformation. Then the probability statement will become a statement that belongs to standard normal random variable. So let's do that. For part A, my probability statement related to a non-standard normal random variable with parameters -3 and 1, I subtract the location parameter and divide the difference to the scale parameter. The left-hand side of this inequality will automatically become a standard normal random variable. So this capital X will automatically become a standard normal random variable according to proposition 2. Now the right-hand side will become what? -3.75 minus -3. We say we subtract the location parameter, but the location parameter is already negative. And we divide the difference to the scale parameter. And that inequality becomes the Z standard normal random variable to be less than -0.75. So all we need to do is to identify that value from the table. That's it. The probability of Z being less than or equal to -0.75 is what? So let me draw you the picture for that. So I am looking for this area. What is the area here? Now that area is exactly equal to the area on the right-hand side of the positive counterpart of -0.75, which is 0.75. So if I subtract the area on the left-hand side of 0.75, then I would calculate my result. And that is this formulation. And the area on the left-hand side of 0.75, let's check 0.7, and we have 0.05 here. And the result that we are looking for is 0.7734, which is exactly written here. Subtracted from 1, we get the probability. So this is how we are going to solve the probability statements related to non-standard normal random variables. So let's solve another one. We have a normal random variable with location parameter 5 and scale parameter equal to 1.2. Calculate the probability of X being greater than 4. So let's do that. First, we start by standardizing this inequality because we can only calculate the probabilities on standard normal random variables. How do you standardize it? By subtracting the location parameter from both sides and divide both sides to the scale parameter. Minus mu divides sigma. Minus mu divides sigma to the both sides. So the left-hand side will become standard normal random variable, and the right-hand side will become 4 minus 5, which is location parameter, divided by the scale parameter, which is going to be -5/6. So the probability of Z being greater than -5/6, which is probability of Z being less than 5/6, right? Again, due to the symmetricity. We have -5/6 here, and it asks the probability of Z being larger than -5/6, which is the total area on the right-hand side. And due to the symmetricity, this total area on the right-hand side is exactly equal to the total area on the left-hand side of 5/6. So the result that we are looking for is phi at 5/6. Now you need to check this value from the table, and you definitely need to apply a linear approximation because 5/6 is a value which is close to 0.833. It goes like this. So you need to apply a linear approximation for 5/6, and you are going to get something very close to 0.7976. Now, for the third part of the question asks, if X is a normal random variable with location parameter 35 and scale parameter 15, what is the probability of X being greater than 52? Now, what do you do? Standardize. How do you standardize? By subtracting the location parameter and dividing the scale parameter by applying this to both sides. The left-hand side becomes standard normal random variable. The right-hand side becomes 52 minus 35/15, the probability of Z being greater than 17.15, which is 1 minus the cumulative probability at 17/15, and that is 1 minus 5 at 17/15. Again, at 17/15, you need to apply a linear approximation between 1/13 and 1/13, because 17/15 is a number which has infinitely many digits after the decimal point. And in that case, you are going to get your result as 0.1285. And finally, for the last part of this question, we have a normal random variable with location parameter equal to 4 and scale parameter is equal to square root of 20. And the question is asking the probability of X to be between 0 and 3. So this time we have an interval probability being asked. What do? You are going to standardize. How? This time you are going to apply standardization to all three parts of this inequality. So from 0, you subtract the location parameter, divide to scale parameter. Apply the same for capital X and 3 value here. And when you do that, the middle is going to become a standard normal random variable, and the boundaries are going to be calculated as minus 0.894 and minus 0.224. We have minus 0.894 here, and we have here minus 0.224. How do we find this area? By looking at the positive counterpart of it. Because the PDF is symmetric around 0, we say that we can calculate the area between 0.224 and 0.894. We are going to subtract the CDF value at 0.224 from the CDF value of 0.894. And for both values here, we need to apply a linear approximation to get a more reliable result. And then the result is going to be 0.2257.